Hello everyone, welcome back to Miss Now Speaks, and today is going to be the second chapter where I'm going to talk about the continuation of integration. So please make sure you watch or refer back to the first video that I make on integration part 1, and then you should continue watching this integration part 2. So what we're going to learn today in integration part 2, I'm going to introduce to you another different type of integration, which is known as definite integration. So in integration part 1, we have learned indefinite integral, and therefore in today's lesson we are going to talk about what is definite integral and how to actually find our definite integrals. So let's move on to a few examples, but before so, let me just tell you how do you differentiate between indefinite and definite integral. So in order to know that you are dealing with definite integrals, all you need to look for is, of course, this integration sign of a particular function. Again, say we want to integrate in terms of x. So you're going to see this upper and lower limit in terms of numbers. So you're going to have a number here, which is also known as the upper and lower limit. Okay, so this A here is actually known as the lower limit, and the B here is actually known as the upper limit. So remember, each time you see the integration that comes with both the figure here that is close to the integration sign, then it is definite integral. And not to forget, the upper limit will always be above the lower limit. Hence, having said that, the B value is always greater than the A. Okay, now we have the first example here. So we would like to do a definite integral of a function x plus 2. And how do you read it? From 2 to 4. So we're going to do exactly the same integration as though it is in indefinite. So integrating x will give you x squared over 2. Integrating 2 will give you 2x. Again, if you've forgotten how to do the integration, please watch back my video of integration part 1 here. And put the upper limits and the lower limits at the end of the square bracket. So what we're going to do is we're going to substitute both the 4 and 2 equally into the answer or the integrated part, and you're going to then subtract the values. So we're going to integrate, we're going to substitute 4 first into the x. So you're going to have 4 squared over 2 plus 2 times 4. And then we're going to minus, and then you're going to substitute the 2 here as the second part. So please always remember to put a bracket, because when you do subtraction and you don't put a bracket, chances of you making a mistake is probably quite high. Counts mistake. So just make sure that you put this bracket. So using a calculator to calculate, then you're going to get the answer is equals to 10. And always remember, the upper limit should subtract the lower limit. Okay, let's move on to another example here. So you're going to integrate 2x squared minus 3x from 1 to 2. So again, we do the same thing. We're going to integrate and integrating this will give you this here. So remember to use the square bracket. Move back your upper limit and lower limit to the end of the square bracket. Let's substitute the upper limit first. Sorry, that is supposed to be 2. So put the 2 in, and then minus. Again, I'm going to stress on making sure that you put a bracket right before adding or right after the subtraction sign, so that you do not make mistakes. Okay, and again, using the calculator to calculate, that's what you're going to have. Okay, so you're going to do the same thing even if you have something that is more complicated. So remember, the lower limit is always a smaller number. In this case, the lower limit is -1, and what you have, something like that. So it's the same thing that you're going to do, but in this case, because I'm dealing with a function that is a little bit more complicated, so I decided to simplify this function first by taking the x cubed to divide with the x square, giving you x, and then I'm going to take the 5 and divide with the x square, and that gives you 5 over x squared. So then we shall move on and do our integration. So integrating x will give us x squared over 2, and integrating 5 over x squared will give you 5 over x. So then put back the limits in, and then put the values. And again, whenever you're dealing with negative numbers, please always use a bracket. It also helps if you put a bracket and that you remember to put in a bracket when you key in the calculator so that you don't make careless mistakes. Okay, and the answer should be -6, so you should try on your own. Let's have one more final example. So one more, and this time we have a function that seems like they need to be expanded first. So I'm going to expand them first before we even try to integrate them. And then, now that you have gotten this, we will actually integrate this one by one. So you're going to have this. So make sure you actually remember your simple integration methods so that it's fast. Alright, and therefore putting all the values in, you're gonna have I like dealing with zeros, and especially when zeros are actually going to be multiplied into a function that only consists of multiplication. So in this case, you have 3x power 4 and divide by 2. So you only need to take the 0 to multiply with 3 and divide by 2. And it's the same thing for all other functions. So having said that, you actually just need to subtract with 1 0, and it's really very easy. Makes life easy. So whenever I see 0, I am really super happy. But don't take things for granted, okay? Okay, so before I move on, why? So this is the answer for example number 4. Because if you have, say, 2x plus 1, and you don't substitute a 0, so because it is not a fully multiplication function, okay, this x here actually needs to multiply by 2 and add with 1. So if you're gonna put in the 0 here, then it is actually not equal to 0 because 2 multiplied by 0 is 0, but when you plus it with 1, there's a 1. So 1 squared is actually 1. So you know what I mean? So if you have a 0 only for a function that has solely multiplication in its operation, then yes. Okay, so I hope you have actually learned additional thing today, which is integration with a definite function and with its upper and lower limits. So make sure you try some questions for yourself. And if you have any comments or any questions, please feel free to leave your comments below here. Till then, see you again. Take care and bye-bye.